Hi everyone. In this video I'm going to discuss negative exponents. Now I'm assuming you've got some idea of the laws of exponents, and if you don't, please watch my previous video that is about that. Let's recap the laws of exponents you know already. My previous video covered the first 5 laws, and this video will be focusing on the 6th law. Like I said in my previous video, the ordering of these laws or how they're numbered, that doesn't matter. Different books or different videos will use different number order for which law is which, but what's more important is that you understand them and you can apply them. Also, what I said in my previous video is that it might be more helpful to think of these as shortcuts, something that can help you instead of getting panicked about laws and right and wrong and all that. So firstly, I've just written here M and N are natural numbers. A natural number will be a whole number starting at 1, and you've got no fractions, no decimals, no negative numbers. So for all of these questions I've got, my exponents are going to be natural numbers. So the laws, number 1, if I'm multiplying 2 powers with the same base, I keep the base and add the exponents. Number 2, if I'm dividing 2 values with the same base, I subtract the exponents. And the reason I've said here a may not be naught is if a was naught, my denominator would be 0 if a was allowed to be 0. So I'm just making sure I don't have undefined situations. Okay, so that's why I've made that exception. Number 3, if I raise a power to a power, I multiply my exponents. Number 4, if I multiply 2 factors together and raise the whole thing to a power, it's the same as each factor having the power. Or if I divide 2 values with each other all to the same power, it's the same as each bit having the same power. And remember, I don't want my denominator to be 0. So again, I'm avoiding undefined values. Okay, anything to the power of 0 is 1, except for 0 to the power of 0. And number 6 is the one we are going to discuss today. Let's consider law 6. So if I have something like a to the power of 0 divided by a to the power of m, I could write that as a fraction, a to the power of 0 over a to the power of m. And I know that a to the power of 0 is 1 over a to the power of m. Now another way I could consider this is if I used the second law of exponents. And the second law of exponents says I must subtract my exponents if I'm dividing with the same base. So that'll be a to the power of 0 minus m, which is a to the power of negative m. So here I've shown that a to the power of negative m is equal to 1 over a to the power of m. You've probably been using this law without realizing, because up to now you might have been simplifying questions like this, a to the power of 6 over a to the power of 8. Now you may have been thinking of these saying there are 8 a's in the denominator and 6 a's in the numerator, so that means I have more a's in the denominator. 8 minus 6 is 2, so that will give me 1 out of a squared. But if I used law 2 properly, I would say a to the power of 6 minus 8, and that would give me a to the power of negative 2. So let's look at some other examples. Now generally, when you ask to simplify questions with exponents, you're normally asked to write your exponents as positive values. So here is my first example. Let's say you are asked to write a to the power of negative 2 with a positive exponent. That would be equal to 1 out of a to the power of 2. So a second example, if I've got x to the power of 4 times y to the power of negative 1, that will equal to x to the power of 4 over y to the power of positive 1, and I won't put the 1 down. Another example, 3b to the power of negative 3. That negative exponent means I'm going to be dividing by 3b to the power of 3. And I can simplify that. I know from the fourth law of exponents, each part Each factor is going to get an b to the power of 3. So that will give me 1 out of 3 cubed is 27, b to the power of 3. And a last example, let's do one with constants, 2 to the power of 2 plus 2 to the power of negative 2. So 2 to the power of 2, we all know, is 2 times 2, 4. And that will be 1 over 2 to the power of 2. And like we know, 2 to the power of 2 is 1 out of 4. And 4 plus a quarter is 4 and a quarter. So I'd like to consider two applications of Law 6 of Exponents, or maybe shortcuts from Law 6 of Exponents. So the first one is what happens when you have a negative exponent in the denominator. Let's figure this out. A to the power of negative m means 1 out of a to the power of m. Now I've got a fraction inside a fraction, not comfortable. Let's rather write that as division. 1 divided by, that's the numerator. 1 is from the numerator, divided by 1 out of a to the power of m, and that is from the denominator. So when I divide fractions, it's easier to multiply by the reciprocal. And so I get a to the power of m. So an easy shortcut to remember is if you have a denominator with a negative exponent, that's the same as having that value, the power, with a positive exponent, the base with a positive exponent, in the numerator. So that's one little application that I find easier to remember instead of working everything out each time. If you want to work it out each time, you're welcome to, but I find that this application saves me time. Let's look at a couple of examples. So, first example, I've got 3 out of 4x to the power of negative 5. So a shortcut for that is if I've got a negative exponent in the denominator, I can write the same power with a positive exponent. Number 2, x squared out of y to the power of negative 3. I've got x squared in the numerator, and now I'm going to write y to the power of 3 in the numerator. And since the denominator is 1, I can just write that as x squared y cubed. Third example, if I've got negative 5x squared y to the power of negative 3 all to the power of negative 2. That's the same as 1 out of negative 5x squared y to the power of negative 3 all squared, because I've applied that negative exponent. Now each factor will be raised to the power of 2. So negative 5 squared is positive 25. X squared to the power of 2 is x to the power of 4. And y to the power of negative 3 all to the power of 2 will be negative 3 times 2, negative 6. And that can simplify to 1 out of 25 x to the power of 4. And instead of having 1 in the numerator, it will be 1 times by y to the power of 6. Let me try and fit one more example in. Let me make a little corner over here. Let's say I've got 6 out of 8, x to the power of negative 4 in the numerator, and y to the power of negative 2 in the denominator. I can simplify my coefficients. What goes into both of them? 2 goes into both of them, 3 and 4. So I get 3/4. Now since I have x to the power of negative 4 in the numerator, that means dividing by x to the power of 4. So that will go into the denominator. And if I've got y to the power of negative 2 in the denominator, that's the same as y to the power of 2 in the numerator. Let's look at the next application of Law 6 of Exponents. So the next application I want to discuss is what if you have an entire fraction raised to a negative exponent. Now let's see. Law 4 says that when I raise a fraction to an exponent, both the numerator and the denominator are raised to that exponent. So that will be the same as a to the power of negative m out of b to the power of negative m. And we know from our previous shortcut, I know that a to the power of negative m will become a to the power of m in the denominator. And if I've got a denominator with a negative exponent, that's the same as multiplying by a power with a positive exponent. And I can summarize this as b out of a to the power of m. So if I look at where I've come, I started at a out of b to the power of negative m, and I ended with b out of a to the power of positive m. What has happened? Can you see that your fraction has flipped over? You've got the inverse. So if you have questions that have a negative exponent, you could work that out slowly and get to what it's equivalent to. Or if you'd like, you can use the shortcut that if you have a negative exponent for a fraction, it means the whole fraction is going to become its inverse. It's going to flip over. Let's look at some examples. So first example, if I've got 2/5 to the power of negative 1, that will be the same as 5 halves, or 5 out of 2. Next example, if I've got 2/5 again, but now I'm raising it to the power of negative 2, that will be 5 halves to the power of 2, which will equal to 5 squared, 25, and 2 squared, 4. One more. 5x squared out of y to the power of negative 4, all to the power of negative 1. So that will be, let's flip my fraction over, y to the power of negative 4 out of x to the power of 2. And since I have a negative exponent for the y, this will equal to, x squared is still in the denominator, but y to the power of 4 will be in the denominator as well. Now, I could have done this slightly differently if I wanted to. Another way I could have gone is I might have wanted to first sort out the bracket. And that would have been fine. So I could have said my bracket is equivalent to x squared, y to the power of 4, and all of that is to the power of negative 1. And then that would equal to 1 out of x squared, y to the power of 4. So generally, when you've got a fraction that's fairly simple, you've just got factors divided by factors, you could work in any order really. If you could either apply the bracket first, or you could simplify inside the bracket and then apply the exponent for the bracket, and you'll land up in the same place. So in our video today, we looked at Law 6 of Exponents. And I also mentioned 2 applications of the 6th law. If you have a denominator with a negative exponent, that's the same as having the same power but with a positive exponent in the numerator. Also, if you have a fraction with a negative power, that is the same as the inverse of the first fraction.